Well, today is a lab day. Normally in class, you would make your very own water bottle rockets. Unfortunately, we can't do that. And this would be difficult for you to do at home because you need an actual launcher that's built for this. So first what we're going to do is I'm going to cover how we make the rockets, or how you would be making the rockets in class. And I'll try to do this relatively quickly, but here's the basic principle behind it. You need either a 2-liter bottle or one of these smaller bottles. They both have the same size opening here for the lids that go on there for it and everything. And the basic principle is this. We're gonna use the water bottle rocket so it's actually upside down. The top of the rocket's gonna be what normally is the bottom of the rocket, and the part that normally you would drink out of, that's gonna be the very bottom. That's gonna be kind of like the engine for the rocket. Now, there are two things that we're gonna put in here. Both of them are fluids, right? First, we're gonna put some water in here, and you usually fill it up about, I tell people, about 1/3 full, not quite halfway full of water. Right, then we're going to fill it up with high pressure air. So what we'll do is we'll fill it up with water. You're actually going to put it on the launcher, which seals it airtight upside down, and then we're going to pump it up with air. And not just a little bit of air, a tremendous amount of air. Now, these bottles are remarkably strong, right? And so if you have a 2-liter bottle, or like I said, one of these smaller ones, and you put the lid on it, I mean, think about this. You can beat on this all you want with different things. You can jump on these things. I've actually seen this, some of these run over by a car, and even then they didn't pop. I mean, so they're really, really strong. And what we're gonna do is, like I said, we're gonna fill it up with some water, and then this part we're gonna fill with a humongous amount of air. And as the air gets squished tighter and tighter and tighter and tighter, normally, right, there's some space between those air molecules, but those air molecules, as more and more air gets pushed into this, they get tighter together and tighter together and tighter together and tighter together, right? And as their space gets smaller, the air molecules don't slow down at all. They're still moving at the same speed, right, for it and everything. And so they're bumping into each other, and the walls of the container faster and faster and faster. And when you're pumping it up, you can actually hear like the plastic kind of like bubbling out a little bit as it gets more and more pressure inside of there. Right, and so we're going to put as much air pressure inside of this thing as we possibly can. And then what'll happen is we'll actually pull out a pin so that we can release a place where the pressure can come out. And then it's Newton's laws right there again, right? Action, reaction, right? The action's going to be that this air is so desperate to get out. It pushes all the water that's below it out of the way, and all of the high pressure air and water comes shooting out the bottom of the rocket ship that we're going to create here. That's the action. The reaction is that the bottle goes flying up into the air. And the cool thing with this example is I mean, these go really high really fast, so it's fairly impressive to actually see these happen. So to build it, right, the first thing is we're gonna need some fins, right? So the fins for this, all you need is a little bit of cardboard, and the fins do not have to be large at all, right? So all I'm gonna do for my fins is kind of like smooth this out, and let's just kind of go like this right here. You just need like a tiny little bit of cardboard, and all that we need to do is, I usually tell people to make 3 fins. So if I kind of do one and I trace it, right, could be the template for the second fin. And then one last time I'll use that first fin one more time. Like this. Some groups, when they're making them, they like to have 4 fins or 5 fins, which is totally fine. But usually I tell people 3 fins is kind of like, an easy way to do this. And then to get the fins to stick on, you just use some tape. Oops, hold on, this way. All right, so you just use a little bit of tape to get your fins on. I recommend put all 3 fins on first, and you kind of want to space them out, so they're kind of equally spaced out here. So if I kind of go like this, yeah, that's roughly 3 fins, and then I'll put a little extra piece of tape on the other side. And normally when we're doing this in class, you get, maybe like a day or 2 in class to actually build these. So I would have you take a little bit more time to make them a little bit prettier, and sometimes people decorate them and build them a little bit stronger, but I think this will work. So we've got 3 fins on our water bottle rocket ready to start, right? So this is kind of like the base of the rocket for it. When you're building these, sometimes I tell people if you want it to do really good as far as as far as going straight up, you kind of either bend the fins over just a tiny bit to one side, making sure they're all going the same way. That way when the air hits it, it actually forces a little bit more air over one side of them, and it actually kind of pushes, you know, the fins so that they're kind of spinning, right? Because, you know, more air is being forced, you know, pushed on, you know, the fins and everything. That'll spin it. It's kind of like a bullet going through the rifling of a gun, right? The bullet gets spinning and that makes it go straighter for it, right? Now, the next part is we need kind of like the main body of the rocket, right? This is kind of like the fuel tank down here. For that, the best thing actually is if you just have a paper towel tube. I don't happen to have one. So what I'm going to use is just some paper. And I'm just going to kind of roll it up just like it was a paper towel tube. You know, kind of like this. And we'll take a piece of tape and kind of tape it all down like that. Right, so this could be kind of like the main body of our rocket, and this is probably the trickiest part of the whole build is you want this to be really straight, right? So if I kind of get it on here straight and everything, and then I take some of this tape, normally I tell students, I mean really you could use whatever tape you wanted, you know, as long as it's reasonably strong, but I've even seen Scotch tape used for this, and it actually works if you use enough of it. But you know, duct tape like this or masking tape works. The best tape actually is packaging tape, just that clear packaging tape, right? But that kind of gets the rocket started like this. The final part is going to be the payload part, right? Just like a real rocket, the heaviest part of the rocket actually goes on the very top of the rocket up here, right? And so for these, either a tennis ball or in this case an old rocket ball, right, works really well. So what I'll do is I'll tape this onto the top, and now, you know, basically again it's Newton's laws of motion, right? Once you have a heavy object in motion, it wants to stay, or it tends to stay in motion, right? So if you have the heavy part of the rocket ship flying through the air and this is the heavy part moving, the rest of the rocket follows along behind it, right? Especially once the fuel is spent, right? Once the fuel is spent, this part of the rocket's actually, you know, not very heavy at all. It's the payload that it keeps following, right? So what I'll do is I'm gonna add a little bit more tape here and there onto this. So I'm gonna tape on the top part of it and everything. And my family's gonna make some water bottle rockets and we're gonna launch them and see how well they do. You take your water bottle and you stick it on the launcher. So it makes a nice airtight seal. You put it on top of the launch pad, and then air is going to go all the way here to our pumper, and we'll pump away and then launch it when it's ready.
Hey everybody, we are here to shoot off some bottle rockets.
We'll just, stop. Dad, we'll just go automatically.
What?
Another one.
Out here.
Let's shoot off some bottle rockets.
Try to make it hold in.
More
pressure.
Hey guys, let's shoot off the bottle
So we'll just go off itself.
I actually don't do peace signs because that's lame.
You're on the video.
Whenever you're ready.
Go.
You go.
We can't technically just call ourselves lame.
No, this one's mine.
Our name's is better though.
Oh no, that's not mine. Whose is this
Rebecca,
Why?
watch it.
one? Pull the string.
How do I launch?
Pull the string.
Look, dude, what is that? It's called bungle. I'm yanking it. What the? Where the heck?
Right on the rock.
Someone slow-mo that.
To go get him in the air. Launch it, baby. It's so cold. Can you video mine?
The harder it is, the more pressure you're putting in.
Oh God, guys, is he dead? What the? Oh God, mine went the highest, baby.
Wait, 1 minute. Okay, here he goes.
Pull it.
Yeah,
Yank
well,
it.
just keep pulling gently.
Oh, it's coming. It's coming. Yeah, mine went the highest.
Woohoo!
I saw it coming from my face.
Great. All right, everyone. You're supposed to use Diet Coke for this, but we only have regular Coke. It'll still work. Josiah is here. He is going to be our stunt Josiah for the day. He is going to be far braver than I would be. And he's loading up the Mentos launcher. Yes, that's a thing.
It's going to launch Mentos?
No, it's going to launch the soda. It looks like you can fit one more in. Not that one. Not that one.
Becca's on it.
Okay, not that one though. We don't want that one. Yeah.
You don't?
We want them to be dry, yep. All right, now we're going to put the lid on.
Wait.
Whoever's touching this, please stop.
Oh, that would be me. I'm stepping on it.
Okay.
Sorry.
All right, the rest of you should probably stand back. Josiah, you can't be over it though. You got to be down. That would be really bad. Are we ready?
Yep.
I'm gonna count down. Oh, you're gonna go back away now, or you want to be close up?
I can't. No, I.
All right, here we go. 3, 2, 1. Oh, it didn't go near as high as
That was
Diet Soda.
super anticlimactic. I thought it was going to shoot into the air.
Diet Soda
I thought